Recordings rolling. It's Wednesday, November 19th. So we have 3 days until Thanksgiving break. And what we're going to do is just pace out the next 3 days. Well, it'll be self-paced, team-paced. So we're going to chew up everything from here to Thanksgiving break. So I'll get you guys this coefficient of restitution lab. That's what I gave you guys this half-page for when you guys walk into class. Okay, so hope you guys a little bit on that in a minute. Okay, welcome back to that. Yesterday, I gave you guys these textbook puzzles to solve, right? And I showed you guys how to solve this in class, and I think I solved a couple of them with you guys, right? But here, I went ahead and wrote the solutions, or well, at least how the step these have to think about. It's the same thing we did yesterday. It's just in written form. So now you guys have this page, so that'll help you guys out, right? And then, of course, I can still walk around and help you guys out. So have both of these turned in by by Friday, so before you leave for Thanksgiving break. Okay? Uh, in fact, guys, if you keep really good pace, like if you knock out most of these puzzles yesterday, and you knock out the slab today, maybe like 20 minutes with your teammates, you might be able to have some spare time to either work on that moment. You guys remember the momentum take-home quiz? You guys remember that? Okay. If you turn that in before the break, then you don't have to think about it over the break. And if you don't quite finish it, then you can just turn in the day after. Okay? Or how about any makeup work? So double check focus, make sure you got everything in, because if you go into Thanksgiving break knowing that you have everything turned in, so that could be nice. Okay? Yeah, if you can keep pretty good pace, hopefully you have some time for I got board games, books, Legos. So yeah, if you get all this knocked out and like between today and tomorrow, you could take Friday and just play board games with your friends. You could do that, which I think would be a good use of your time because it's good to have a day like that every once in a while. Right, so what's the skill vision restitution lab? Right, so on this half page, you're pretty much going to copy this. So write your name. Right, so everybody write your name on their half page I gave you guys. Okay. Title is coefficient restitution lab. Okay. And then going to create this table, and I'm going to have you also create a graph at the end. Okay. So this is going to be coefficient of restitution. Right now, I'll come back to this. So I'll leave this up for most of the class, so you guys have that. Right, but connect this back to the physics ideas because, of course, a big idea of doing these labs is what's the physics principles behind this. Right? Coefficient of restitution is a way to quantify how bouncy is a collision. Okay? So at one extreme, you might have something like this. Is that called, what kind of collision is this called again?
Inelastic?
Yeah, inelastic, where they stick together. Okay. And then if they two objects do stick together, okay. If you look at coefficient restitution, the sort of textbook, sorry, guys, to do this. What's the difference in post-collision velocities compared to difference in pre-collision velocities? Okay. You take that ratio. Okay. So, guys, if two objects stick together, what's the post-collision difference in velocities? Zero, because they have the same when they have the same velocity, so the difference velocities would just be zero. Right. So would this whole coefficient just be zero? You see that? Right. Now that's an extreme condition. That's extreme. That's as small as coefficient restitution could ever possibly be. It could be zero. That just means they stick together. Right. What's the other? Here, let's say you go the other extreme. What if you have a perfectly bouncy collision like that? That's probably about as close as to perfectly elastic as I can get. What do you guys think the coefficient of restitution is for perfectly elastic? Where this is equal to this. And that would make this whole coefficient equal to 1. Yeah, 1. Right? So perfectly elastic, yeah, this comes out to 1. Okay? Now, keep in mind too, velocities are vectors. So if you have opposite directions, do you have to subtract a negative? Here, let's run a numerical example. Suppose this was coming in at 7 units to the right, and this is 3 units to the left. What's the difference in momentum? They don't say 4. Yeah, 10, right? Because 7 minus -3. Okay. Or even if you just did velocity, like here, these are velocities. Okay. Okay. So 7 minus -3 should be 10, and so on. Okay. All right. So you guys got that? No, I'm gonna have you guys do a modified version of this where you bounce them off the floor. And there's a different perspective on coefficient restitution, but mathematically it's the same. So the two objects colliding here could be the ball you're gonna bounce. Maybe bounce this one, a little bounce here. The ball and the entire what? Starts with an E. You're standing on it now. Earth. Earth. Between the ball and here. Well, guys, isn't the Earth from our frame of reference basically not moving? Right? It depends simplify a little bit. Right? So if that's true, then the difference in velocity between the ball and the Earth would just be the velocity of the ball. Okay, so you're just subtracting 0. Okay, did you guys remember from conservation of energy days that like Galileo dropping balls off the tower, that the crash speed is square root 2gh? You guys remember that? We derived that a few weeks ago. Right? And also, if you want to go way back in this class, you can also get it from kinematic days. Okay, and then you can, so if you measure drop height with a meter stick, you can calculate how fast it's going to crash into the ground, or into the tile floor. Okay? And then if you measure the rebound height, well, you can also calculate the rebound speed. Right? And then if you take that ratio, the 2g cancels and you get this expression right here. So this is what you guys are going to use in your calculation today. You guys got that? Okay. All right. And then you guys are basically making this right here. This is my poster version of the lab you guys are doing. Right. Like that. All right. Which brings us back to this right here. Okay. So I have a big old bag of balls in the middle room. You guys see that big old bag of balls? There's all different kinds. There's bouncy balls in there. There's ping pong balls. There's tennis balls. There's racket balls. Right. So I want you to pick one ball with your team. So pick your favorite one. Just pick one. And just drop it from 5 different heights. Right, can you guys get 5 different drop heights? Can you guys measure that in centimeters? I'll give you guys the meter sticks. All right. And then measure the rebound height. Okay. Can you guys use that to calculate coefficient of restitution? Guys do that? Okay. Guys, isn't that just this right here? This right here? Okay. Okay. Something like that. So you guys do that. Okay. And finally, I want you guys to make a graph. What is rebound height compared to drop height? So rebound height in centimeters, drop height in centimeters. What do you guys think that graph is going to look like? And of course, the data will naturally create a graph anyway. But you guys made that. Right? All right. So go ahead. You guys got the next 3 days to do this lab, which can probably take you guys 20 minutes. To also finish these textbook puzzles, which some of you guys might be finished already because I walked these through yesterday. We did these, right? And also you have the solutions all right here. You can just follow these solutions. Okay? And yeah, if you want to turn your momentum quiz early, you got plenty of time for that. Any makeup work? All right, so go ahead and pace out your time wisely with your friends.